students who are in different time zones can view this later. So welcome to 6858. It is my pleasure to have our first guest lecturer, Maximilian Burkhardt from Airbnb. We're going to have a few guest lectures in the next couple of weeks, looking at different aspects of security that is encountered by today's engineers and practitioners. And so today we're going to see an enterprise web security perspective from Max. And Max, welcome. Max is in San Francisco, I believe, and the floor is all yours. Thank you.
Thank you, Professor. Hello, everyone. My name is Max Burkhardt. I'm a security engineer at Airbnb, and I work on a lot of web application security aspects. Today, I'm going to be talking about my experience making security happen in industry and focusing in on a project I worked on last year to build better capabilities to monitor and deal with attacks against our web application. We'll get into that in a sec. So my very brief intro is that I did my undergrad at UC Berkeley, studying computer science there, and then went into the industry in a pen testing or sort of offensive security role at InfoSec Partners, now called NCC Group, and have since transitioned more onto the blue team defensive side of things at Airbnb. So it's great to talk to you all here today, even though we are, have to do this remotely. But one thing I kind of wanted to start out with is asking you all what effects you think the COVID-19 situation and the resulting effects of that is having on security teams or defensive practitioners around the world. What have you heard, or what do you think might be happening to these security teams as we kind of grapple with this new way of working and new way of living? Franz or Nikolai, do you want to? Maximilian, you were speaking. Great name.
Yeah. Sorry. No, thank you.
Please go for it.
I was reading that there were a lot of attacks, or there's increased. I mean, since everything's remote, there's a lot of requesting for communication, and there has to be this kind of, there's more insecure, like emailing and things like that, because you can't just walk down the office to confirm that the person you think sent a message.
Yeah, for sure. A lot of companies I've heard of weren't very well equipped for suddenly an entirely remote task force, and this has required a lot of very fast changes as to how we enable people to work remotely, or the sort of procedures. So this is one I think Airbnb was a little insulated from, because we've had work from home policies for a long time, but I know a lot of companies have had to really scramble to suddenly bring up VPNs for all of their workers, and how do we verify that things were actually correct? Yeah, that's a really good one. Anyone have any other ideas of stuff that might be going on for defensive or offensive teams?
I think this COVID-19 crisis kind of poses a really big data security policy, because a lot of companies, like banks are the first thing that come to mind, work with sensitive client information. And it's tough as like a manager to make sure that lower level employees are like practicing data safety.
Yeah, a lot of companies really relied on this sort of idea of like, well, when you're in the office, that's where you're handling information, and the information doesn't really leave that. And this is really showing that that's not really the case. People are taking devices home. They may be connecting from bizarre, unusual networks. There's a lot of challenges there in validating that the data that you're protecting is really staying safe. Some other things I've heard of include really huge traffic surges as people use internet products more, especially for companies in the communication space, and that's adding a lot of strain to systems, which can sometimes make security response more challenging. Another thing we've been seeing is COVID-19 related phishing. So people trying to get folks to open attachments or click links, or do unsafe behavior based on the claim that, oh, this is some sort of information from the WHO or the CDC, And these are fairly despicable tactics, but they're absolutely things that people are using. And so this is adding a lot of new challenges suddenly for security teams. Great. Yeah, thank you for speaking up. I hope we can kind of make this somewhat interactive, even though this is an entirely remote session. So feel free to post in the group chat or just say something, and I'll try and get to you. Zoom will, I think, bring up the folks who have spoken most recently, so I should be able to see you there.
Max, there
So
was one question in the group chat. Somebody said, like, a lot of researchers, security researchers are bored at home. And, and so as a result, attacks have gone up.
It's possible. We are seeing a lot of activity on our bug bounty right now. So people are definitely at home and maybe looking for more things. Hopefully some researchers are working on some cool defensive work as well. But honestly, the more people that are out there looking for vulnerabilities and reporting them in a good way, the better. It really makes us all a lot safer. Cool. So moving on to just a brief preview of what we're going to talk about over the next hour and a half or so. I'm going to start off with why I'm very glad you all are in this class and why we need more people like you working on security in industry, and why this is such a critical field for people to get proficient in and then hopefully specialize in after that. I want to wax philosophical a little bit and talk about what is security and what I see as our task as an industry or a group of professionals or academics trying to keep things safer for the world. The bulk of this presentation will be my sort of making security happen segment, which is where I'll be talking about a project that I was on that was part technical, part process, specifically around web application security and how we deal with incidents once they happen. Not just the preventing of vulnerabilities, but if you assume that a vulnerability is going to happen, how do you effectively deal with it after it does? After that, I'm going to, show a little bit of what sort of the things that made this come about, and talk about a security incident at Airbnb in our web application layer, and how some of this work was inspired, and also how some of it saved our bacon to some extent. So I wanted to give you an example of what that looks like in the real world. And then finally, I'm going to talk a little bit about some of the places I think you all should consider with an InfoSec career. I've seen a variety of different approaches towards going into security. There's a lot of them, and I hope I can just give you some advice about ways to make that fun and impactful. So let's jump into it, and I'll be pausing for questions at various points, but again, feel free to jump in if you like. So I want to start off with a little bit of history. About 20 years ago, there was an advisory published in this CA 2002 called Malicious HTML Tags Embedded in Client Web Requests. And this was basically an advisory about cross-site scripting, which you may remember from web security recently. So cross-site scripting, the injection of JavaScript into target websites in order to compromise sessions, has been a problem for a really long time. This is not something that is brand new. 20 years ago, there were advisories about it. This certainly wasn't the first time that somebody had noticed that XSS was potentially a problem. So this has been around a long time. However, just last year, I saw this tweet, and it's a tweet, so I'm not 100% sure of the veracity here, but I think it's reasonable. Somebody found a cross-site scripting vulnerability in Google's main page and apparently a lot of their subdomains. And that could have a reasonable amount of effect, right? Cross-site scripting can steal sessions, it can possibly compromise user data, and that's a bummer that, even a very well-funded company like Google could be vulnerable to something like this. And I want to be extremely clear that I'm not saying Google has a bad security team or is bad at dealing with XSS. They have one of the best security teams out there, and they've contributed a ton towards tooling and process and various mechanisms to try and make vulnerabilities in their site as rare as possible. From 2015 to 2016, they paid out over $1 million in cross-site scripting vulnerabilities to bug bounty researchers, kind of demonstrating their willingness to pay money to deal with these problems. And so they're really well equipped to kind of avoid cross-site scripting issues, and yet they still fell vulnerable to one just last year, even though this is something we've known about for 20 years. So there seems to be kind of a problem here. And my hypothesis of what's going on is that security is not really scaling along with the rest of information security. There was sort of old guidance that said, you want to do a pen test on everything. You want to make sure skilled humans try and find vulnerabilities in your software, make sure that there is a security review before somebody starts implementation, build security early. But the problem is that there just aren't enough skilled humans doing this. There are a limited number of people with security expertise, and they are busy with a lot of things, and people are building new systems all over the place that handle more and more sensitive information, and there just isn't necessarily people to cover those. So as kind of an example of this, some of the companies that we trust a lot in order to protect our data are things like the credit companies, Equifax, Experian, or TransUnion. And yet, how many of those have people from this class interned at or considered taking an offer from, right? These are companies that handle very sensitive information, that play a pretty critical role in handling user data, but they don't necessarily have the ability to hire the top security talent because that talent is very rare and very expensive. So we need to think about ways to make security scale better in order for it to protect things equally. I saw a question in the group chat, sorry, I just got to it now, but the question was, what are offensive and defensive security teams? I'm going to talk a little bit more about this at the end when I talk about future careers, but yes, in short, offensive teams will tend to try and find vulnerabilities so they can be fixed, and defensive teams are trying to prevent vulnerabilities or patch them after they show up or detect if they've been exploited. We'll be going into that in much greater depth in just a sec. So it seems like we kind of have this scaling problem. Vulnerabilities from 20 years ago are still present, and our sort of normal advice for dealing with them doesn't work for all companies, and in fact often only works for the ones that seem to be the best resourced. And the other thing is that it's not just old problems that we're dealing with. It's not just the XSS from 20 years ago. We are finding new security vulnerabilities and new challenges every day and with every new technology that comes out. Things like containerization, Kubernetes, advanced, distributed systems are bringing a lot of cool new opportunities and letting app services that get spin up in very powerful new ways, but they're also bringing new problems, right? These are changing how trust works across networks and how people get access to things, and so that's bringing a whole new set of problems. Blockchain gives an opportunity to write some really interesting applications that have very different trust models and can do a lot of stuff that old centralized systems cannot. But if you watch blockchain news, you'll know, it also means that there's a lot of opportunity for small mistakes in implementation to have major security effects. And it just so happens that generally when there are problems with blockchain applications, there's often a lot of money on the line, and this can be particularly damaging. And then finally, there's what I kind of consider the crazy dark magic of the security world. A lot of very interesting academic research from things like Spectre and Meltdown to Rowhammer, and these basically attacks that are taking these fundamentals that we assumed about our systems and our platforms and kind of throwing them out the window and saying, okay, actually, you can't entirely trust your CPU not to do the wrong thing, or RAM may not always have the values that you expect. So there's a lot of challenges here, and you might be wondering, why would you ever get into this field? It seems like everything is more or less on fire and stuff is getting compromised all the time. But really, I think that that risk and that opportunity of fire is why this is so interesting. There are huge opportunities out there, even today, even though we've been trying to do security for 30, 40 years, there are huge opportunities in changing how the industry does it. And there have been approaches that have been tried over the preceding few decades, but I think there's a often agreed upon inference that what we've been doing so far for security hasn't worked. And so we need innovation and fresh thinking, and we need to work at that sort of bleeding edge of the combination of technology, new technologies that are coming out, as well as new processes, as well as just new ways of looking at the world and deciding how are we going to defend it in order to change the paradigm and allow defense to start winning. So I think a classic example of this is that, if you look at any sort of security trade conference these days, there are so many companies that are promising combining machine learning and security. And this is, I don't think it's really been nailed yet, but this is a classic example of picking stuff from other disciplines, finding other technologies that are, changing other parts of tech and trying to make them work for security and generally improve the state of everything. So security is a fun area to go into, and it is so powerful to spend time on because I think it's a particularly creative field. What I'm going to be talking about is some defensive technology that I built for Airbnb, which has a particular tech stack and culture and business model. And I hope that it's applicable to a lot of things. But one of the things that you'll find as you go in and start trying to implement security in a few places is that one size really does not fit all. You can take the security principles you learn here in this class and end up implementing them in vastly different ways, depending on what your environment needs and what sort of resources are available to you. So when I say different tech stacks, like the COBOL-based unemployment system that sounds like a lot of states are using is probably going to need pretty different defensive technologies and approaches than something like a Ruby on Rails app that Airbnb deploys. And the threat models are different, right? Who is attacking your system might change what sort of levers you pull in order to defend against them. And then budgets and company cultures often can influence what sort of things are at your disposal, right? Can you purchase a really expensive vendor solution, or are you going to want to build something more in-house? Or can you rely on open source technologies or more community-based systems, or are you going to have to build something that is much more custom? Or can you lock stuff down, or is it more important to give employees and users and administrators more access and then just kind of keep an eye on what they're doing and detect potential abuse? So all of these things are elements that you're going to have to kind of mix into your thinking about how you deal with security problems. And I think that's what makes this a exciting and sort of lifelong career, right? You're not going to solve something once and then carry it everywhere. You're going to have to keep changing it in order to defend the particular situation that you're looking at. So I've been saying the word security a bunch, but I failed to kind of define it the first time. So I want to take a very brief philosophical detour and talk about what do I really mean when I'm saying security, because you're in a security class, but as you've probably noticed, you've covered a giant range of material, and this seems to be this really broad area. So when I say security, what am I actually talking about? So it's a really wide range of work and problems. So there's this quote that I saw once from somebody who ran a security company. It says that a system is secure if it behaves precisely in the manner intended and does nothing more, which I think might be a reasonable definition, but it is not honestly super helpful, right? What is the system's intention? If you get out into industry, you'll notice that there's not a lot of formally verified web servers out there. There's not a lot of official spec that describes everything that is going on. And so let's try and define this in a way that seems a little bit more usable. I see security as a strategy to address risks to a system. So as you step into a system, you're trying to figure out, like, how do I defend this? You have to think about, okay, what are the threats? Who might want to cause the system harm? Who might want to extract something from it that they're not supposed to get? And how do we respond appropriately? How do we address those risks in a way that keeps things running and allows the business to continue as expected, but still makes us more secure? Well, I think there's kind of a high-level algorithm to do this. So you try and be very threat agnostic, right? You are aware of the threats that might come at your system, but you want to be flexible because you know you're not going to be able to enumerate all of them. You want to build protections close to the assets that you're trying to protect. So if you have a database with personal information in it, you want to make sure that database is well protected. That way you can kind of deal with internal threats as well as external ones. You want to assume that some defenses are going to fail. You've probably talked about zero-day attacks or zero-day vulnerabilities in this class. You know, times when an attacker finds some sort of vulnerability that nobody knew about before, even if you were fully patched, you wouldn't have been able to defend yourself against it. Stuff is going to get compromised. So you have to think, okay, well, when things get compromised, how are we going to have defenses in place that still keep us safe? And when something gets compromised or a defense fails, how do we know that that happened and how are we able to respond? And that's an area that we're going to talk about more today. And then finally, keep self-assessing. Resting on one's laurels is never a good idea in the security field because stuff is moving very fast. And there's always things changing, both in terms of what the attackers can bring to bear, as well as what your own environment is doing. Something that I love about working at Bay Area tech companies is that stuff gets changed and built and rebuilt constantly. And so there's always new technologies in play and exciting stuff to work on, but it also means that you can't rely on something getting locked down and being declared secure and then just leaving it there, right? Stuff is always going to be moving, and so you always need to be thinking about what sort of issues are out there. So why is this so hard? You know, I just described, I think, a reasonable high-level strategy for dealing with it, and let's just go out and make stuff secure. But I always think of this sort of quote that in theory, there's no difference between theory and practice, but in practice there is. Now, modern information systems are moving very fast. They're built on growth, so they're going to be adding new things and implementing new features and collecting new data all the time. And if security can't keep up with that, and if we can't scale to meet the engineering goals that are being pushed by everyone else, it's not going to happen. So there's been a lot of discussion in industry, and this has been going on forever, about how do we make security scale better. And I think there are some strategies I hope I can share and that I hope might be useful to you as you go out into the industry and start trying to do this. And so with this, we're going to kind of move into the section of making security happen. How do we have a security problem we're trying to solve and then build up systems to solve that in a way that scales and allows us to protect the fast-moving, exciting technology that we're all trying to provide. But before I jump into that, any questions so far about this philosophical stuff? I promise we're getting to tech stuff soon. I know that's what you're all here for. Okay, cool. Don't see anything right now. Well, we'll jump into this. And of course, if you have any questions, please feel free to shout them out or put them into chat. So I mentioned a little bit earlier about the problem that I was trying to solve here, which is security visibility on our web application surface. So I need to start with a little bit of context about incident response. This may not be an area that you have covered too extensively yet, but it's an interesting kind of subfield of security of when a vulnerability gets exploited or a user account gets compromised or something is broken into. How do you detect that that happened, and how do you find out what the impact was or kind of what the aftermath was so that you can respond appropriately? You've probably seen a lot of news articles about, oh, so-and-so was breached, there are this many records stolen. This is kind of about that process of how do you actually find that number? If you realize that something weird happened, how do you actually know what happened, who were the attackers, what did they take, etc. And so this is a pretty important problem and something that people have been building tools to deal with for a while. There's just, probably hundreds of various tools that you may have run into in security internships or on your own or anything like that. These are all things that are designed to both detect exploitation of systems, track attackers as they move through a system, and generally give you sort of insight into what's going on in your network. And if there are malicious folks inside, how do you stop them or prevent them or things like that? But there's kind of a category here that we found was missing. And it's not obvious because you probably haven't used these tools, but it's web applications. So what about the web apps? All of these tools that I was talking about, and a lot of the material you'll see if you go take like a SANS forensics or intrusion detection class, is about sort of an older or more traditional style of attack. So if we talk about attacks briefly, a very common sort of process you'll see described, or you'll hear about a lot if you're taking a class about network pen testing, is that you have some sort of attacker and then they will phish someone and get access to maybe the laptop of a contractor, and then they might pivot, meaning that they move through the network and change their base of attack in order to get access to a developer machine, and then maybe they'll get into the deploy system from the developer machine, and then they can escalate their privileges to get into production, and now they have access to the payments database, and here they can get credit card information or things like that. Like, this is an attack chain that has been pretty well described and understood, because this is a lot of how attacks started, right? There were these sort of hard shell, soft center networks that attackers would break into and then move around inside and then get to the data that they were after. And so this was a big problem. And so a lot of these tools and processes were built to deal with this. And the tools that I showed on the last slide are doing a pretty good job of observing that sort of the middle layer here, this corporate network. They have agents that run on user laptops or intermediary servers and can detect suspicious or malicious activity. So if when the attacker gets on that contractor laptop, a tool might detect like, oh, somebody has logged in here, and they might be able to see the strange traffic between that laptop and the developer machine and kind of deal with that. But the problem that we saw at Airbnb was that we also had this web app. Airbnb.com is mostly a web application, and the web application has its own set of vulnerabilities that you could potentially be worried about. And so an attacker can use something in the OWASP top 10, cross-site scripting, SQL injection, all these various web attacks that you've probably heard about. And the web application already has access to the database because its job is to make payments and store stuff in the DB and things like that. And so suddenly this is this big route of access that those tools weren't covering. OWASP is the Open Web Application Security Project, and it's basically an open source kind of group of people that's trying to track stuff about web application security and vulnerabilities. I recommend you check out their site. It's a cool project, and they have this thing called the top 10, which is what they consider to be the top 10 vulnerabilities in web applications that you should be thinking about. It's always contentious, of course, to declare really what are the top 10, but it is a very good start if you're trying to wonder, like, what are the major things that are affecting web applications and how do we go about defending these? If you're ever looking for a job doing web application pen testing, it's a great resource to look into. So this was, we considered a sort of gap in our incident response capabilities, is that we had all this information about people possibly traversing the network to access data, but if we have this powerful web application that also has access to that data, how do we make sure that attackers don't get in through that and go on to steal data from us? So there are 3 challenges that we sort of identified as the reasons why this was problematic. The first one I want to actually talk about is the diverse stacks problem. So diversity is really fantastic from a engineering perspective and a resilience perspective. If you want to be able to write your web app in kind of whatever language you want, using whatever stack you want. And this is something that Airbnb engineers have taken to happily. So we used to be a Ruby on Rails application. We now have a lot of things written in Java or Kotlin. And there's some Node.js in there too. So Airbnb actually has hundreds of various web applications serving parts of what you see as Airbnb.com. And these are all things that are exposed to the internet in some way, right? Because they're handling traffic that users send them from all over the world. They need to be exposed to some extent. And so there's this big pile of different application stacks and web servers and technologies that are serving all these different types of requests. And that sort of lack of standardization actually gives us kind of a security problem, because we can't just write one Ruby on Rails security plugin and apply it to everything, right? We can't say, oh, well, Ruby on Rails apps don't do this, so if we ever see something doing this behavior, we can flag it as malicious, because there's actually a lot of different things that different web apps do, and you can't say for sure something that applies to everything. So diversity, although valuable in a variety of ways, it helps you write applications with the right tool for the job, and it makes sure that one vulnerability in like sort of a core library doesn't affect everything. But it also makes sort of building a framework for security and incident response pretty challenging. We also saw there's a lot of missing instrumentation. So the sort of systems incident response that happens on laptops and servers and with those tools, computers have been being broken into for a long time. And so operating systems kind of figured out like, okay, these are the sort of things that need to be logged. We need to log whenever somebody logs in with something, when new processes start. Like there's a lot of this information that's relevant for security that was already sort of present for systems and incident response. But we found that in web applications, sort of that default output was missing, and we weren't being given the information we needed to build the context about what was happening on the web app in order to defend it. The final area where we were having a big problem is the amount of noise that we were seeing when you try and look at requests on a major internet-facing web application. So has anyone here run a web server on the public internet? React with yes if you have. 1, 3, yeah, okay, yeah. So a lot of you, okay, cool. I see over 10 responses. A lot of you, run web servers, which is great, and you may have noticed that often within minutes of putting it up there, you might start seeing weird traffic or somebody with what looks like a SQL injection payload coming to your web application or something like that. There are attackers all over the place on the internet, and they're often just spraying their attack payloads across everything. And this means that if your strategy to follow up on web application incidents is, oh, if I ever see somebody with a SQL injection payload sending it to Airbnb.com, I need to respond, we would never sleep. There's a tool called SQL Map, which is a sort of automatic plug and play SQL injection tool. And this, if you run it in its default configuration, it tells you that it's SQL Map. It's not trying to hide or anything. And we get a few thousand requests from SQL Map every hour. People are just throwing it at everything they can reach in the hopes that they might find an application that's vulnerable to something. And so this means that there's this huge noise problem that we have to filter out these sort of basic attacks that aren't doing anything and find, okay, what are the ones that actually landed? What are the attacks that we need to seriously worry about? What needs to be actually investigated? In the chat, I see, yeah, WordPress requests. Yeah, WordPress, hugely popular blog software, had a lot of vulnerabilities for a while, still does to some extent. And this was very profitable for attackers for a while. So a lot of places will just assume that everything is a WordPress site and then throw exploit payloads at those in the hopes that something will land. So these three problems kind of contributed to our need to build something that was going to do a better job for us. And so our approach was try to set up a framework. And so I mentioned the point about diversity. We needed something that wasn't going to just work for our one main web app or just for new web apps that we built. We wanted something that was sort of a combination of technology and process that could apply to everything that we had exposed to the internet. If we purchased a new company through a merger or something, that we could protect that. How do we build up the system so that when there are web application vulnerabilities discovered or exploited, we have a reasonable way to respond to them? So I'm going to talk about these 4 areas. The first one is about metric tracking. So I mentioned earlier that one of the cool creative things about security was that we want to be able to borrow from other disciplines. And I think this is something that we're going to be talking about a lot more in the next few slides. there are some things that have been built by other disciplines of computer science and the tech industry that are going to be really helpful in giving us sort of the context about what people are actually doing on the web application. A default web server will often tell you things like, okay, what paths are being requested by users on a web server, and what IP address did they come from? And some of this can be useful from a security perspective. But we found that for what we were caring about, that are missing some kind of key context, because we needed to answer some basic questions about the traffic that was coming into us. So some questions are things like, what are all the requests that Alice has made? You know, in a particular session or on a particular day, Alice is sending a bunch of requests to Airbnb.com. What are all of those? How can we look at those specifically? Device tracking also ended up being kind of useful, and I'll show you why in a sec. You know, if there's a particular iPhone that has used Airbnb a few times in the past, what are all the requests that device has made, and you know, are there patterns we can extract from that? And then also, are there requests that look like they might be attacks, right? There's this set of tools called web application firewalls that try to look at incoming web requests and detect malicious patterns that might indicate a cross-site scripting payload or a SQL injection payload. And these have had kind of a challenged history because they're in sort of a tough spot. Identifying attack payloads is very hard, and often there are sort of ways to evade this sort of detection. But there are ways to extract useful signal from this, and I'm going to talk about that in a sec. So first off, tracking devices and users. This is valuable because this lets us kind of build these reputation systems about a particular user or a particular device and understand, is this something that we need to look into more, right? If there are anomalies in terms of the attack traffic that something is sending or the number of requests a user is making, then we can sort of pick out these signals in the noise of, oh, this could be an attack that might actually be doing something interesting. And actually, the advertising industry, the ad tech industry, has been doing this for a long time. And traditionally, security and ad tech have not gotten along super well because of the whole privacy thing. But they've actually, you know, gotten pretty good at figuring out, like, okay, how do we establish context for a particular device over a long period of time or a particular user, and how can we utilize that? So let's kind of look at an example. Here I have 2 lines of logs from our web server. All of the information in logs and stuff you'll see here is redacted, so you won't actually see real data here, but it's very close. So here we've enriched some logs to include, in addition to the standard stuff, user ID and a device ID. And so the user ID is some, you know, ID that's associated with user accounts in Airbnb system. And the device ID is basically a random identifier that we give to devices when we first see them. So it's stored as a cookie or something like that. And just by adding these 2 elements, we are starting to see something kind of interesting in the logs here. These are 2 requests that are about 6 seconds apart. You can see in that timestamp there. And it appears to be the same device, but suddenly there's a different user that is making a request to the site. And so there are benign explanations for this. Maybe the user you know, had 2 windows open and they're logged in as different accounts or something. It's possible this is not malicious, but there's a possibility here that a user's account was just taken over, right? That there was some sort of vulnerability that allowed a malicious attacker to send a request as a different user, and that might have just been exploited. This is something that isn't confirmed by this log, but it's giving us context that we didn't have previously. Similarly, if we see that the same user is making requests from 2 different devices in a very short period of time, again, there are very reasonable reasons why this might happen. You might have it open on your Airbnb open on your laptop and your phone, and you're using both at the same time. But you can enrich this with other information like, where are those devices physically located? If one device is in California and the other one is in New York, that is less likely to be the same person. And so is it possible that, again, a user's password was just stolen and suddenly it's being a user's account is being accessed from a totally different device, and might this be something to look into more? So this is the sort of additional context we want to build into the logging we're doing. so that we have this base of information to make decisions on when I get into kind of the next step, which is querying. I also mentioned, finding malicious requests. It's a really hard battle to try and say like, okay, we're going to detect everything that's an exploit request and then block it before it hits the web application. If you try and start building that, you'll probably end up with something that can be evaded in some way or another. But that doesn't mean it's not useful. If we know that a particular user has sent us, 3 SQL injection requests yesterday, and then now they're doing something else that's strange or anomalous, that might be something worth looking into. So we can use this as a valuable input into sort of a smarter system about how do we classify traffic in order to deal with it. If you kind of have your attacker's hat on, one thing you may have noticed about this is that a lot of these things that we've built, or that I'm talking about, could probably be evaded, right? Identifying devices on the web is pretty hard. You can usually corrupt your device identifier or select a new one or things like that. But I think an important point to make here is that when we're talking about these sorts of tools to cause attackers friction, there's still value in something that if it can make the attacker have to go slower or have to go through a lot more work in order to carry out an attack. For instance, if an attacker realizes that users are being tracked and looked for anomalies, then they might have to then make a lot of user accounts in order to carry out a particular type of attack. And that is a noisy action, or that might require them to pay for a botnet. Or basically you can kind of force them in order to do things that make their attack harder or noisier or more easy to detect or thwart by having these sort of signals in place. So we're not building a perfect system here where nothing is going to get through, but what we're hoping to do is lower that noise floor of random web requests and increase the likelihood that when an attack does happen, we have some chance of catching it. So that was sort of our first element, which is let's make sure that we are logging the right things so that we have this context when an attack happens of what went on there. The next bit is about efficient queries. So it turns out when you kind of go ham with this idea of let's log everything, let's make sure we know what is going on, you end up with a ton of logs, and they're actually very difficult to manage in a reasonable way. So our web servers see about 1.5 billion requests every 24 hours, and we have it extremely easy because Airbnb doesn't actually serve that many requests as tech companies go. Because of the nature of our business, we make money without people sending a ton of requests. You can, go to Airbnb and book a listing with probably hundreds, maybe 1,000 requests compared to other companies like maybe Google, which is serving ads. And so, the dollars per ad is very low. And thus they're serving, billions and billions and billions of requests every day. And so they have a lot to look at. So, but even at our sort of modest scale, 1.5 billion requests is a lot to look at. And if you're trying to add in a lot of information, a lot of context, efficiently querying all of that is going to be challenging. And we're talking about incident response here, right? So this isn't something where you necessarily have 2 weeks to look into something. If there's some sort of malicious activity detected, it's likely that somebody wants to know in the next 24 hours, what happened, what was taken, etc. So I'm going to describe kind of a basic strategy. One of the first things we implemented about how to take this information and make it useful and effective in sort of an incident response scenario. So there's some basic data science we can do, and I'm not a statistics expert, nor am I particularly good at machine learning or anything, but we can actually build a lot of valuable stuff with some basic statistics. We don't have to go pay for fancy artificial intelligences that are going to learn from all of our traffic and try and build some sort of crazy model. There's some basic computations we can do to look at the data, determine anomalies, and then surface information very quickly to help with dealing with an incident when they occur. And so this is just a start, right? There's a lot of value in going further with this and actually building those models and going further with that. But the goal here is you have a web application, you like to defend it. What's the easy and cheap things you can do first in order to defend that? So I'll talk about what we built. So we have this system called Apache Airflow, which is sort of like a fancy task scheduler. And we set up this Airflow system in order to periodically look at the logs in our system and then run some computations on them in order to sort of like surface various slices of this data that is more valuable. And we want to detect anomalies with some simple statistics. I see a question here that we're building a log infrastructure. How do we decide what information would be most valuable to log? This is a tricky one because a lot of it is kind of built with experience on when we're in an incident and we're thinking like, oh, dang, it would be really useful if we knew X, and then we have to go build that X thing for next time. Those three things I talked about, the context about what user is performing an action, context about what device is performing an action, and are there tags on this action that indicate that it might be malicious, have been our most valuable things. Those are the ones that when an incident comes up, no matter kind of what it is, those are the things that have been most useful to know about. So let's go through a basic anomaly detection example. We want to take all these logs that we're collecting about requests people are making to the site, and then split them by the HTTP methods, so like post, get, put, etc. The URL path, so that's everything after the slash in the URL, and what user is making that request. And then we're just going to use the most basic of all aggregations, count, and see how many times is a particular user like kind of hitting an endpoint. And then we're going to calculate the mean and standard deviation for the global population there, and pick out users whose requests to a particular endpoint are vastly different than what the global population is doing. And so this is a very simple data processing thing, right? You can do this with more or less pure SQL. And it sounds pretty trivial, but there are two types of attacks which are particularly damaging and particularly common, that this is actually pretty good at surfacing. So the first one is the insecure direct object reference. You may have seen this before, but basically the idea is if there's some sort of API that takes an ID of an object to look up. So like here an example might be, we want to look at the user passport photo with an ID of 1. And if there aren't good access controls on that API, you might be able to change the ID in that URL and get other people's passport photos. This sounds like ridiculously trivial, but it's actually pretty easy for this sort of thing to happen if your application doesn't have a good framework to deal with this. Because developers might build a system where there's no obvious way to see somebody else's passport photo, but they don't realize that an attacker can change this request and then load somebody else's data. But one thing I'll note here is that if you want to extract significant amounts of data here, you're going to need to hit this API lots of times because you can only really fetch one object per request. The other vulnerability that this tends to pull out quite nicely is blind SQL injection. So as a very quick refresher here, with SQL injection, you're adding new database logic that is going to get executed on the database server. And sometimes you can't actually see the output of those new queries you've made. And so there's this technique called blind SQL injection where you are going to be able to execute some sort of conditional inside your SQL injection request. And then based on the output of that, you can usually infer one bit of information. So a kind of classic example here is that maybe we can execute some SQL and we can character by character brute force the password of an administrator from some table here. So this is sort of a basic example of that, where we're going to try and every request guess like, oh, is the first character M? If yes, then like let the request succeed, otherwise fail. If there is the first character of the password N, try again, et cetera, et cetera. And so again, we have this case where you have to make a ton of requests, and if they don't, and if you don't make those requests, then it's going to take a very long time to get anything valuable done. So having that basic information about like, oh, what are the anomalous numbers of requests ends up being quite useful. So this is kind of stood out to us, and so this is why we built this as one of the first things. And this is valuable on two kind of sides here. One is forensic examination. So once you've determined that a vulnerability exists, did anyone exploit it? That's pretty good to know. The other thing that it is useful for is if you have your anomaly detection tuned well enough, then you can actually detect people exploiting vulnerabilities actively this way. And so this is sort of what you're driving towards, is how can we notice when suddenly a endpoint is being hit an odd number of times from an odd user or an odd set of devices? Is this something we should look into more? And so this is what allows us to not be driven entirely by these manual approaches to finding vulnerabilities. We can start listening to the attackers doing stuff and determining where they are looking particularly. Great, so now we have a bunch of logs and we can now query them more efficiently, but the other thing we realized we needed was sort of the right tools to have in place. So this is a bit of information that maybe be more useful to you to come back to when you are trying to build a system like this. But what we found really is that the things that are useful in this sort of process are a lot of times kind of classic data science tools. So we used a lot of Jupyter notebooks, a tool called Superset, which sort of visualizes things, Kibana to search logs. The technologies we're using here are not fancy security, information systems. It's the tools that are efficient and fast and give you the power to think about data in a sort of aggregate way. And this is great because this means that we can leverage all of the cool tooling and systems that are being built by the data science and data analytics community in order to help security along the way. So these are the tools we primarily use. Depending on what your situation is, you'll probably end up with different stuff, but don't constrain yourself to, oh, what are the security tools I need? Think about, we're building all this information about security context. How can I query that efficiently? The other thing that ended up being critical to us in various points is how can we halt exploitation to something very quickly? It depends on what sort of enterprise you're in, but usually the time in between making a code change and having that code change be live is some number of minutes to hours or days or even months. And you usually don't want to tie your incident response process to this code deploy process. So at Airbnb, we're relatively fortunate, and a lot of times you can get code out in under an hour to the global population, which is fantastic. But at the same time, you don't want to wait 45 minutes with somebody still taking data out of your vulnerable SQL injection endpoint. So we converted some tools that had previously been used for sort of denial of service defenses, and converted them so that they worked well to instantly block access to a particular endpoint. So we could basically say, we've discovered that there's some sort of vulnerability here. Let's set the allowed rate limit on this to 0 and make sure that nobody else can send requests to it anymore. This often can sort of break part of the application, but this does allow us to move much faster in terms of sort of stopping the bleeding and making sure that no additional exploitation is going on while we investigate. The other area that sort of was key for us to have in place early was ways to make clients upgrade. This is more of a tactical thing, and I won't spend a lot of time on it, but there are certain vulnerabilities that really require the client to do something different. For web applications, this is pretty simple, but if you have an API that's hit by mobile apps, making sure that those mobile app users upgrade their their apps is pretty crucial. And Android has some really nice tools for this called inline updates, but on iOS, you kind of have to implement your own system. So just, keep a post-it note about this one. If you're building these defenses for these APIs that are hit by mobile apps, thinking about a way to make sure that your users can upgrade so that they get the latest security features is a very useful lever to have in place. The final sort of element of this framework that I want to talk about is planning. So this, if one thing from this presentation sticks with you, and I apologize for straying from the technical here again, but when it comes to incident response, if somebody comes to you and says like, oh, we've been hacked, there's some sort of compromise, look at this giant vulnerability, the most important thing to remember is to respond, don't react. This was told to me by an incident responder at one point, and it has really kind of resonated with me. There are so many things you can do in sort of the heat of an incident and the surge of adrenaline that comes with realizing that somebody has exploited a vulnerability in your system that can actually make your job way harder. It's very easy to accidentally tamper with evidence, alert an attacker that you know they're there, all sorts of things that come from sort of reacting immediately as opposed to taking a measured response. So actually, the planning parts of incident response are some of the most crucial, because you need to make sure that when that sort of incident happens, you're responding in a way that is measured and planned. So I'll talk about a few little key parts of sort of what our plan is for web application incidents, just in case they're useful. So first of all, enumerating where incidents can come from is actually pretty valuable. Because different types of sort of these entry points are going to give you different parts of different information about context and what sort of information is available to you, etc. Some of the major areas that we keep an eye on are things like bug bounty reports. So if somebody reports a vulnerability to us that is sufficiently serious, we want to make sure that nobody else has exploited it, or there hasn't been any active exploitation going on. Similar to penetration test findings, if you hire a company and they say, oh, turns out there's SQL injection on this publicly exposed endpoint, it's very interesting to know, like, oh, was that exploited at some point? And then, of course, there's the scarier areas of somebody comes to you and says, hey, there are these weird logs in my service, and you look and it looks like SQL injection payloads, or seeing your own data on Pastebin. That's always pretty horrifying. And then, of course, your own instrumentation that we talked about, if well-tuned, might tell you, like, oh, there is an anomalous amount of activity to this particular endpoint, and it's isolated these small number of users, and we think this is something that should be looked into carefully. So thinking about each one of these entry points can kind of help you build that process for how you respond. Then you've got to identify the vulnerability. This is easy if you started with something like a pen test finding or a bug bounty report. But otherwise, this is where anomaly tracking really comes in handy, is where are we seeing strange activity? What correlates with the timing of some sort of data leak or something? And here, talking to your experts is pretty key. So security teams can't work in vacuums. We can't understand this wide range of application behavior better than the developers who build it. You can if you spend a lot of time on a particular thing, but when you're trying to protect a whole attack surface, you need to be able to use the knowledge of the experts that actually built these systems. Finding patterns in affected objects can also be useful. Like if you see a lot of user data leaked, were these users all in the same experiment, or are they all from the same geographic region, or do they all like stay at the same Airbnb host? These sorts of data can be really helpful in kind of narrowing down what the vulnerability was so that you can fix it. Then you kind of get to this analysis and post-mortem stage, which is really what we had to improve on, which is when we know the vulnerability existed, how do we find out if anyone else found it, if this was exploited at some point in order to take information, and do we have to notify people about some sort of breach? So something that has changed how we respond to this, notably, is there's this little bit in our the General Data Protection Regulation, or GDPR, which says that basically when there is some sort of breach of information or something has been accessed, you have to report it to regulators unless the data is unlikely to result in a risk to the rights and freedoms of natural persons. And let me tell you, when you're in the middle of responding to an incident, it is not great to have to think about, oh, are we potentially risking the rights and freedoms of natural persons? It's actually a pretty hard question to ask and get an answer to. And so GDPR has kind of caused this thing that we call timeline compression, which is where, because of these breach notification requirements, within only a few hours of knowing that something might have happened, you have to get a very good picture of what was taken, who took it, is there a risk to users' privacy? Because like the GDPR is, I'm personally a fan of it because it is really making companies think about, okay, when we lose data that is potentially affecting the people whose data this is about, and how are we responding appropriately. But that means that you have to get a lot of information very quickly in order to kind of make that judgment. And that means that these sorts of tools to pre-aggregate information about where are there anomalies, when do we see data that is entering or leaving the system becomes particularly valuable. So the activation of the GDPR really underlined a lot of the sort of trends that we were seeing beforehand about how do we make sure that this sort of data is available quickly and early. So, this is work that tends to not be possible after an incident's already happened. Log aggregation and analysis and sort of building these processes, you often can't come up with it on the fly as you're trying to work on that 72-hour deadline. So that's why this is an area where it took planning for us. And we've been building it over time in order to be more and more ready when stuff happens. So next up, I'm going to talk about a real world example, but I wanted to pause here and ask if there are any questions about sort of these framework elements so far. This sort of process of tracking the right metrics, building the right query capabilities, having the tools in place, and having the right planning. As I mentioned, the goal is building of this framework because we need to be able to protect all the applications that everybody is responsible for, and hopefully also kind of share this with other companies that are trying to defend things similarly. So, any questions so far? At what point do we ever take action against a user, banning them, taking legal action, etc.? A good question. So, legal action is I don't think that's something that Airbnb has ever undertaken, though I haven't checked. There are certainly things that we do to interfere with users that we can get good signal on them being malicious. And so our trust team calls these frictions. But this is things like rate limiting. If we see that a user appears to be like sending spam or something, if we see somebody that is like trying to do some sort of IDOR or SQLI attack, we might apply that as well, kind of reducing their ability to easily send thousands of requests from one endpoint. There are other things we can do because we have to assume also that just because a user is sending malicious activity, it might not actually be that user who's at fault there, right? Like somebody's account may be taken over by an attacker because they had a weak password or they lost access to their email. And so we might not want to actually punish this good user. We might just want to kick out the attacker that is currently in their account. And so we can do things like force them to verify more information about themselves before they can send any more requests, things like that. So it's actually, there is a series of things as we kind of track the life cycle of a bad account. I see a question, does the expectation of fast instant response means that you always have to be online / ready to respond? To some extent, yes. There's sort of a agreement of for different types of vulnerabilities, does the response have to be within minutes or hours or days? And so we sort of have this classification of when we get the sense that something bad is going on, we kind of assess what level of severity it is and then respond appropriately. But there are people who are on call at various points in order to be able to respond quickly. The types of vulnerabilities that my team deals with are often the sort of things that we can deal with within hours, which means we are not always woken up at 2 a.m., but it is important that there's always somebody who's like online to respond to some extent. There are other folks who are kind of on the minutes rotations, which is always an exciting place to be as well. Do we follow GDPR guidance for incidents in all countries, or do we have to determine what user's data was taken, which legal requirements apply to each incident? I mostly leave this to our legal team, who is often involved when it kind of comes to questions about what's disclosure requirements, that sort of thing. Our main job is to make sure that we're providing them as valuable and accurate information as possible about what sort of was in scope for the incident. And then they can make the judgment call on what the regulations apply. From my understanding, it's quite a complicated synthesis of regulations, some of which apply based on where incidents happened or who was affected. And so we often find that's best left to the legal experts. What are examples of breaches that you wouldn't have to report under the GDPR guidelines? So like a GDPR is really concerned with user data because it's for protection of data subjects. Something like Airbnb source code being stolen would not really be covered under the GDPR as far as I know, because it's Airbnb corporate information, not user information. There have been attacks that are not suspicious from the log entries alone. Yeah, I'm not going to say this is perfect, but what we found is that for most attacks, there is something that was amiss that could have been caught earlier. And so generally, we're not going to be able to build an instrumentation system right the first time that's going to catch all things, but we can try and determine of the attacks that have happened, where might we have caught this? Like, where could there have been a log statement saying like, oh, this is unusual about this request, and fed that into kind of a bigger system. Cool. Raiden.
So I saw from your earlier slides that your log streams are enriched with a lot of authorization information. So does the security engineering team work with the engineering team to implement the authentication logic, or do you guys have some sort of service discovery plus proxy solution that enriches these kind of log sources without sort of engineers having to explicitly do it themselves?
I guess I'd say a combo. Our goal is to work very closely with the engineering teams in order to kind of make that security information available. And so we kind of are playing this balancing act of how can we make sure good security information is available, but it's also easy to use and people don't notice it. So like in this particular case, we worked with a team that owns the API gateway to do that enrichment. So it's transparent for all engineers. Like they don't really have to think about, oh, I need to make sure I'm logging user ID here. But it was built in concert with this team that kind of owned this central piece of infrastructure, so that it's not that security is just going and putting code into other people's projects. That often doesn't scale very well. We're working with the relevant system owners, but trying to do it in a way that applies to as many engineers and stacks as possible.
Thank you.
Yeah, sure thing. Cool. All right, I'm going to talk a little bit about this vulnerability. Want to make sure we get through all the slides here. And talk a little bit about how we were able to deal with it. So this is a story of a bug that came in through our bug bounty program. You can find us on HackerOne, hackerone.com/Airbnb. If you've ever noticed anything or have any bugs to tell us about, we'll pay you. This is a story about one of them. And so I guess shout out to Rooting0x01 on HackerOne for this find. I don't think that person is in this class, but you never know. So kind of the context here is that we have this functionality called freeform events, which is that when you are on a trip, you can add a new event that kind of goes into your itinerary. Your itinerary automatically has where you're staying and sometimes your flights and stuff like that. But if you want to add a specific event to kind of just like view in the same field, then you can do that. And it's a kind of basic create, retrieve, update, delete type API. And so on the wire, simplified, if you want to get information about a particular event, it looks kind of like this. So just to kind of start off here, if you had one request to attack this with, what sort of things might you try? Any guesses about what you would do to this request to possibly steal some data? See, play with the number at the end or try other IDs. And yes, that's exactly what we're going to try first. It's sort of the first thing to try here, the IDOR. And unfortunately, it appeared that if you adjusted this integer ID at the end of the request, there was some amount of user data that came back, including email and name. And these are, of course, pieces of personal data that we care very much about protecting. So yikes, we've got an API that is revealing data about users, and all the attacker has to do is change the ID. And so this is not great. Somehow an endpoint was implemented without the proper auth check. And there's actually a whole story about, how did this happen? How did this get past those defenses? But we don't have time to talk about the day. So we're just going to talk about how we kind of responded to this report. We know now that there's a vulnerability that might leak data about people's email addresses, so we've got to deal with that. So we sprung into action. We have PagerDuty, which is kind of how we get notified, connected to HackerOne, our bug bounty platform, via, again, this sort of scheduling system, so that as soon as this was verified as a valid report, our team could get paged and we would know like, oh, there's something we need to respond to right away. So this kind of just shortening that timeline in between discovery and confirmation of an issue to the point where we can fix it. We then had to find, get the right people in the room and find the team that was going to go solve this problem. Where there's a few, at this point, you're kind of actually getting some organizational engineering of, okay, we have an endpoint name. How do we find the people who built this? And that's kind of an interesting other area of stuff you have to build sometimes. In this case, we had two routes available. We could identify the web service that was powering this endpoint and then find the registered owners of that service. We could also kind of escalate through an incident process that was built for dealing with availability incidents. So, of course, Airbnb also cares about going down, and we could kind of use that same process to determine, we treat this endpoint like it has gone down, and how do we find the people to bring it back up? And sort of parallelize the response. The dev team is going to fix the bug as quickly as possible, and the security team needs to understand exploitation, determine if we need to block this endpoint right away, determine if there's data being stolen here, etc. So because of our sort of pre-aggregated metrics, we can, in a single query, say like, have there been any anomalies on this type of path since this endpoint was implemented, or like, we just want as wide a range as possible. And so we were able to run queries like this and very quickly determine, okay, there weren't anomalies here. As far as we can tell, there have been no unusual requests to endpoint. And we can then start kind of crawling through these logs in order to make sure that no exploitation happened at all. But what we're able to get there is that we can really quickly identify if there appears to be large-scale exploitation of this sort of issue, or if somebody is trying to move really fast to get this data. And this helps us change our engagement with that sort of immediate process. Based on the information we gathered through our pre-aggregated data, we determined like, okay, we don't think we have to block this endpoint. We don't think that in these minutes, somebody is compromising this data. We can let the dev team get their fix out, and no one's experience is going to be impacted, and no one's additional data is going to be lost. But then, because of our additional instrumentation, we can also do things and say like, okay, we can look back and look at every request that's been made to this endpoint and determine the user making that request and make sure they were actually authorized to see that information. And so this is how we can get better confirmation that even though vulnerability existed, it wasn't actually exploited in order to breach user information, and therefore our users' data was still safe. So this is the sort of things that this sort of metric collection and anomaly tracking really changes the story about how we can interact with these incidents. Cool. So that's kind of the framework we built. We're continuing to add on new metrics, new queries, better tooling, but it's something that we're sort of suggesting as ways that people can more effectively deal with these incidents. I see a question. Have there been breaches on anomaly tracking software? I'm not, ours, as far as we know, no. There is a history of web security or security tools that try to look too closely at untrusted data, possibly being vulnerable themselves. So like antivirus programs have a particularly bad history here because they're trying to analyze all of these executables that they see, and then they're vulnerable to things like buffer overflows and stuff like that. So there are some risks there. We feel reasonably confident in the systems and languages with which we built our anomaly tracking systems, so that they're not as vulnerable to that sort of issue. So I've been talking about kind of this approach that we took, and kind of taking it back to that original idea of like, how do we scale security? This is how do we figure out one set of data to collect, one set of approaches to undertake that is going to work for that wide range of services that we're protecting, and that, you know, diversity as well as cool range of technologies that we get to protect. So I'm going to take a few slides here briefly. I know we have about 10 minutes left to talk about some other technologies I think are really doing a good job of not trying to solve security problems the old way, but are really moving things forward and defending users in a way that's kind of compatible with 2020. Because basically this is just the security stuff I'm really excited about. First off is sites without passwords. So I think users have kind of demonstrated that they can't be trusted to handle passwords securely. There's a lot of password reuse. It's hard to remember passwords that are particularly long. Password managers are great, but it is difficult to convince the whole world to use them. And so there, I think, are some very cool proposals for how we get people away from passwords with things like magic links. So you just enter your email, have a link sent to your email that has some sort of random identifier, and then basically by proving you control that email address, you get into an account. Slack does this under certain circumstances. There's a standard called WebAuthn that is using public key cryptography and hardware tokens, so you can sign into a site with something like your phone or a YubiKey. And these are really changing, I think, the game here in terms of making it so that users can't be phished as easily, password breaches don't happen, password reuse is impossible. Really powerful stuff there. Universal second factor security tokens are, I think, a fantastic example of really making cryptography very easily accessible to the average person. So in this case, really what I mean by cryptography accessibility here is that, you know, you plug in a device and press a button and then bam, you just did this, you know, public key exchange. That's an awesome user interface that really makes people significantly more protected against phishing. So the U2F protocol is kind of built to deal with phishing problems from the beginning, and you can't do these sort of relay attacks against it that allowed you to steal things like the TOTP codes that were previously used. So U2F is another fantastic area, and if you don't have a U2F token, I recommend going and trying to get one. They're a really good way to upgrade the security on your accounts. Finally, I think, you know, the fact is modern platforms like iOS and Android, they're sandboxing things by default, and this is going to make native security so much better. You look at the face of malware on iOS and Android and see that the sort of challenges that users are facing with regards to the threats they see on their own devices are really fundamentally different than the old days, right? Malware still exists, it's not going to go away, but what malware can do and how easy it is to find it and stop it is really very different than it used to be. So people are making really big advances here in terms of making security easier to use, as well as ensuring that the average person is not going to be quite so easily compromised. So those are awesome examples of scaling, I would say. The last few minutes here, I'm going to finally cover that question at the very beginning about kind of your InfoSec career and what does it mean to go into security and what are some of the areas that are available here. So there are a lot of ways to do this. There's a lot of different types of people who hunt security flaws or build defenses against them. These first two I can't really recommend. In addition to being morally bankrupt, well, you know, you can make an argument for hacktivists, but these are not particularly good economically either. There are a lot of really great ways to go into security and find vulnerabilities and build new defenses that both pay well as you know, push all of security forward and keep the users safe, which is really what we're all after. So when I said offensive teams, there's a lot of space in terms of finding vulnerabilities. Either you're on a penetration test, and so you're trying to uncover vulnerabilities in software that someone has built before attackers do, or you're trying to test a network and determine like what are the you know, detective controls that are in place. How can I evade that intrusion detection? How can I go from standing outside a bank in a parking lot to compromising you know, the card data that is within? There's some very exciting stuff here, and I mentioned this is kind of how I started out. It is incredibly fun when your exploits land and you can figure out how to get past those defenses. It's also really good at building a diverse skill set. So because you're looking at this massive range of software and systems, you have the ability to try a lot of things, which is great. On the defensive side, you're up against very hard problems. I'm going to say it straight up. It's very hard to defend systems in this day and age, but as I said, it's creative and I find it very fun. There is something incredibly rewarding about being able to identify these threats and eliminate them and eliminate bug classes one by one. In the defensive side, there's a lot of just software engineering to be done. So here you aren't maybe necessarily like dealing with exploits on a day-to-day basis, but you might be building software that is crucial to the defense of a particular network. So this is a blog post I wrote a while ago about building a cryptography services framework that kind of extracts the difficulty of working with cryptographic operations away from engineers who are not on security teams. And that's something that was built by software engineers at Airbnb. You'll see this a lot of other companies as well. Security engineers, you have to know the game and both sides of it, how the attacks happen, how they're defended against, really a sort of hybrid role in which you are using your knowledge of how exploitation happens in order to make sure that a system or company or government is well defended. Intrusion detection is also this whole other area that I think has a lot of interesting engineering problems in it. And so there's a ton of cool work both in engineering systems to do detection, prevention, analyzing malware, analyzing attacks, things that you can do to really be the worst nightmare of the folks on the offensive team who are just trying to go and land some exploits and you're making it very difficult for them. So to kind of wrap up here, and I want to leave just a handful of minutes of for questions at the end. My goal and what I hope all of our goal is here is to change the game and make it so the defensive teams start winning. We need to be more efficient with how we're applying security effort and make it so that these protections scale with the applications that they support. Security, I think, is an engineering problem. And there's some really excellent engineering that still lies in front of us as we go and try and make a more secure world. So regardless of whether you're kind of on the offensive or defensive side here, I think we can all agree that things should be compromised less. Regular people or, even, everyone involved shouldn't have their credit cards stolen every month. Elections should not be influenced by malicious parties, and nobody should fear that the photos on their phone will end up on their internet. So without their intent, that is. The way I try to approach being a security engineer is that it's not about trying to prevent just one company or community or group from being compromised. It's about how are you building and engineering solutions that are going to kind of level up everyone and build us a more secure world. So that was about all I had for you today. We really got close to the end here, but I'm happy to take any questions and I can hang out on the Zoom if that's okay. I can also connect with me on Twitter, or you can email me here, root@maxp.fm. If you have any additional questions, I am happy to be a resource. So thank you very much for having me.
Max, thank you for giving a great lecture, and always good to hear what's actually happening in the real world, and this issue of understanding data and data logging and actually working with it, how important it is. That's something that is often overlooked, I think. Yeah, you can stay in the room in the Zoom meeting at all, no problem at all. And anybody who wants to ask more questions, please stay around and let's give Max a round of applause, a virtual applause. If you want, there's a hands button thingy under more. But thank you. And we'll stick around.
Thank you all for having me.
I have a question.
Please.
I'm wondering what you think about the trends are, what the trends are in terms of security companies and services. Do you think that there's going to be increasing kind of segregation and outsourcing to larger security companies that handle more of the services for companies, or do you think that going forward, big software companies still have to have their own security teams?
It's a very good question. I think that there's a lot, kind of going back to the security is creative point, I think there's a lot of security that really needs to take into account specific threat models and architectural decisions made in a particular network. And so that's going to make it difficult to outsource entirely. So I think that as you see a tech stack become customized, as many big tech companies choose to do, there becomes more and more need in order to have a in-house security team or a very customized security effort in order to defend that. So one of the things I think is challenging is that because there's so much emphasis on customization and like building your own whatever it is, whether it's a logging system or web server or framework, it's going to be difficult to have things that are off the shelf and are truly effective. So I think it's going to be a little bit of a combo of companies realizing they can do more with open source or off the shelf components, and therefore utilizing kind of the community's knowledge on how to defend those things, right? Like I think a great example of this is Kubernetes. Kubernetes is really growing in popularity as a way to manage a lot of containers in a production environment. And the more people that use it, the more we can build knowledge and understanding of like, okay, this is how you defend Kubernetes, and these are the tools that you can use to like kind of drop in and add in some security features. So the more that we can do that, the better. And I do see a future where a lot of tech companies are able to utilize resources like all the things that come with AWS and many of the other cloud providers. With a click of the button, you can get things that were very hard to get previously, like messaging queues and like queuing systems and really advanced storage systems and stuff like that. And so the more that we can kind of have these off-the-shelf components, then we can kind of have these standard defenses that apply to protect them. So I think we're going to see a combo of people using more standard components in order to build their systems quickly, and therefore being able to import more security for that. But there will always be a core of who's going to think about the specific security problems that this group faces or this company faces, and how do we solve those. So it's going to be a bit of a mix, but there's always going to be that creative element.
I have another question if no one else has
Go for
one.
it.
I'm wondering, who do you follow in the security space that you go to for news, or who just generally who you admire? What are the resources that you like?
Good question. I mean, I think most of my security news and commentary comes from Twitter, for better or for worse. The InfoSec community is very active there. And so there's always a good range of perspectives and viewpoints to get there. And so I guess I can give some recommendations of who to follow. Take all of these recommendations as like, I find these perspectives interesting. I can't necessarily say I endorse 100% of what all these people say. But I think kind of the top two people that I always listen to when they, or I'm looking at when they tweet, are Alex Stamos, who is at Stanford, and Dino Dizovi, who works at Square. And Dino keynoted at Black Hat last year. I think they both, they kind of are discussing in different areas at the moment, but I think they're both very experienced viewpoints that are very interesting to look at. And then as you watch them, you'll kind of see a network start to form of other people who are kind of in that space. It's hard to have a list of exactly these people are really valuable, but you kind of build up this network as you're watching these conversations go along. So I'd recommend starting with those two, and then scaling up your Twitter intake as long as that's still mentally healthy for you. I recommend screen time. It's a useful feature.
Thank you.
Great.
Okay, Max, I think great job. Thank you very much.
Yes.
And
Thank you
maybe
so
next
much.
year we'll see you in person again.
Yeah,
Although
yes, I would
this,
love that.
I must say this worked out really well. Quite very interactive, and it was great.
Cool. All right. Well, thank you all, and I hope to see you in the flesh sometime.
Yeah. Okay.
Bye-bye.
Good. See you.